that says the recent, let's say, changes in the power system area. I chosen 30 years because I started, working at the university in 1994. So it is 31. So the changes that I've seen. And the first one is the introduction of the wholesale electricity market, the development of distributed generation then, so the generators that are connected to the medium voltage, and also technological advancement in both power plants and the availability of communication. And 30 years ago, probably the phone calls were very frequent in the control room. Nowadays, there are other methods and monitoring and control systems. I would like to focus also on the ongoing changes, in particular for the distribution network. And the first point is the participation of the end users in the electricity market, how to involve also the final consumers in the electricity market. So there are some schemes, regulations, so we can also see, I've put just the numbers of the European regulation, but just to have a reference, but it is common everywhere. And then the electrification of the heating also during the winter, and the electrification of power, our private mobility, electric vehicles, and the spread of data processing centers. In general, we say, okay, there is an increase of consumption of electricity. In Italy, the consumption of electricity does not increase too much. It was increasing in the history until 2007. And then in 2007, 2008, something was happening, I don't know, in the economy. And then it is almost flat until now. But we see that there is a much increase of consumption from the data center, from internet or artificial intelligence and so on. So they require a lot of power. We focus here on the changes of the distribution network. So changes of the load, I said data storage, heating for the house, heat pumps, and transport, electric vehicles. There is no much increase of use of electrical vehicles in Italy until now, but the future, who knows, no? These are, and this figure shows what is the change for the distributed generation. So this figure shows the profile, the average residual demand in that is the flow in the substation that is feeding a distribution network in 2010 and 2015. This is an average for all the substation or many substations in Italy of the profile of consumption during the day of the power from the transmission network to the distribution network. And you see in red the curve in 2010, so the typical curve with a peak in the morning and in the evening. And then for the same transformers, this is an average, no, in 2015, so 5 years later. And this is the blue curve here. You see with a very decreasing peak and very steep ramp in the evening. So the decrease can also be below zero. So the flow is not coming from the transmission network to the distribution network, but there is a counter flow from the distribution network to the transmission network, because there are a lot of photovoltaic panel or distribution generators and no load in the distribution network. So, and this happens not during the night, but during the day, in the middle of the day, because there is a lot of solar production, and then a sudden increase of consumption from the distribution network, not only because of the human activity, but also because the sun is going down. So there is a sunset, no? So there is, and so there is this that curve, they say that. So a steep increase that put in some input. Another slide that I would like to mention here, it is the reason behind that, and probably one of the reasons is the cost, the economy, and this is the levelized cost of energy. That is this is the equation. It means that the money that you need to get from the production for the entire life of the power station in order to recover all the costs, initial cost, maintenance of the fuel, and so on, all the costs. So what is the total, the money, no? And this is the levelized cost for all the life for the various technologies. And you see that the technologies, there is a very big change. You see here it is for 2008 to 2018, so 10 years. And there is a technology in which the price is going down. And it is a solar photovoltaic, rooftop or utility scale. 81%, 77% of reduction of the cost just in 10 years. This is behind the fact that in these years, many people find it convenient to install the panel photovoltaic in the rooftop and use it. Oh, there is also this slide that I wanted to show, that there is a big change in the communication, the possibilities that we have now to coordinate and to speak about the possibility to transact directly from the final user, that is the scheme that I will show to you, is that the communication facilities are evolving, and they are much updated. In the past, I mean, the system operator used mainly the phone calls and so on. And nowadays, there is a spread of possibilities of communication, also with optical fibers and so on, also in the distribution network. Since 10 years, 20 years, but probably 10 years, also in the substation, in the distribution network, the operator of distribution network just have the knowledge of the measurement of the current in the initial part of the network, in the connection, the substation, without much of monitoring of what happens at the end or at the end of the feeders, even though. And nowadays, they in general have a view of what happens in the entire network. And this is also the microgrid, and that will be a topic for the last day. There is a concept of for the transaction of the power for the final users. That is the concept that if a user have some facility to produce electricity, then in the traditional framework needs to inject, to give this power to the utility. And in general, the utility gives to the final user a very low price. And the user that needs to buy electricity needs to buy electricity from the utility. But the utility applies a price that is completely different from them. In general, it is double or something like this, because there are also the costs and so on. So the idea behind this peer-to-peer transaction, parent transaction, is that the final users that wants to produce electricity can sell electricity not to the utility, but to the neighbor. So that needs some, and this can be a neighbor very close, in the same building, because in the same building, in particular for building with many apartments, flats, and so on, maybe they agree to put a solar panel on the rooftop, and then the solar panel produce electricity. But this electricity, it is not good to give to the utility, because you get only few amount. Okay, you can feed the common service, but they are only few. They want to feed also the various apartments. So they need a scheme, a regulation that allows them to share this, the production of the rooftop photovoltaic for the various apartments. And this is in general called this collective self-consumption. So there is the self-consumption of the house, isolated house that has the rooftop panel, but there is also the building with many flats that share the production of the photovoltaic, the common photovoltaic. But we can also extend this idea and say, okay, there is a community, many buildings nearby, that can share. Obviously, we cannot share or transact from one user located in one distribution network to a user that is another part of the network, because then it is difficult to say to the utility, you don't have any role. He has a role. He has the role of transmit this power. In this case, you see in the same building with the rooftop panel, we cannot say that the utility has any role, because the utility does not own the wires inside the buildings, and it does not play any role. In this case, we can see that the role of the utility is minor, because they are quite close to each other, so they don't create a flux, a power flux into the network. They don't create any congestion. They solve the congestion. They don't create losses because they are very close. So they can be considered as energy community, a community. So we can apply the same regulation of the collective self-consumption also for this community. This is the idea of the changing of the regulation in Europe that allows this direct transactions between the final users. I'm not able to say to you how it is working, the legislation or the regulation in Europe, because I have not understood. But the idea is that these directives, these laws, these rules that are put in practice by the European Union at the union level are then applied in each country in their own way. So they can also be different. So there are always some difference on what happens in Italy with respect in France and so on for the same regulation. Yeah.
In case of these energy communities,
yeah,
suppose there is some energy trading between two energy communities, then who has the control over that flow?
Mm-hmm. For the actual regulation, there is no transaction between the community, but only between the members of the same community. So in general, in the old regulation, you say that the power that can be transacted, generation and consumption needs to be equal. So the needs to be balanced, and so only the balanced energy can be can obtain some incentives or can be subtracted by the bill with the utility.
So it's like intra.
No, but the idea of exchange between the communities is outside the regulation. It is not more this idea. This is just like a system that is not autonomous, because each of the members of the community has their own contract with the utility or the various resellers with the difference in price and so on. But they create this community in order to exchange the power, but only the power that is generated and consumed inside the community, within the community. Yeah, is it clear? Well, that is good. So these are some few things of renewable energy communities that mention this clean energy for all European package call. And the idea behind this is also social, so it is linked with many things, and energy communities are seen as a scheme capable of circumventing barriers for further deployment of electrical power generation units from renewable resources. Why this? Because in general, when you design a photovoltaic panel or a local generation, you take into account only the local load. So you don't design a very huge photovoltaic unit for a small house with a very small consumption. And if this user is inside a community, probably can sell electricity also to the neighbors. So can install, if there is a space or there is the opportunity, also a larger unit than the first one, or also install storage because it is needed. But this will be the case. And also, this has so many things. So it is linked with these goals of the typical goals for affordable energy, clean energy, sustainable cities and community, responsible consumption, and climate action, because there is an increase of use of renewable resources. I would like just to end this talk with showing some slides with a project, with a community in Bologna, where we are very involved. This is Bologna, and there is a part of the city. This is the center of Bologna. There is a part of the city that is this part, mainly residential, but also commercial and area. And in this area, it has been established a community that is called GECO. You see here the units that are involved: 200 kilowatt photovoltaic panel, 30 kilowatt thermal biogas plant, and 100 kilowatt PV system to other photovoltaic plants. So these are the things that are involved. And just an example for the joint acting self-consumption idea. So the community, CABA is the center, the structure in which has been installed this photovoltaic plant. And if you don't have the community, the photovoltaic production is just used for the consumption in the same site, so in the cab, that is the place where the photovoltaic unit is installed. And if there is overproduction, this production it is sell to the grid, to the utility. If you have a community, the other participants of the community can take this power from the photovoltaic units. And of course, inside the community, they are free to establish the price that they want. So there is a freedom to choose also a price that is convenient both for the owner of the photovoltaic unit, that can sell to a higher price than that one recognized by the grid, in general the wholesale electricity price, and also convenient for the other participants, because probably this price is not so high as the one that is required by the resellers. And this scheme also allows the financial sustainability of the installation of the photovoltaic unit, of the distributed generation. In this table, you see here the net present value, and you see that if there are no other participants in the community, so you need to relay just for the self-consumption, and you see that you can see that most of this part is red. So it means that from the point of view of financial sustainability, you have at the end losses. You have minus, so you don't gain anything. and only if the self-consumption is above 50%, so you install a very small photovoltaic unit so that the self-consumption is above 50% of the energy that is provided by the photovoltaic unit, time by time, no? You have a financial sustainability. If you increase the number of other participants in the community, so instead of 0%, you increase this percentage, you see that you get green blocks also with a low self-consumption percentage. So you can install a larger facility in the same installation. There is also one aspect behind this creation of energy community is that they need in general an infrastructure. In order to have benefits for this balancing, in general they need to install a storage system, and there is also a need to coordinate the various units, in particular if the community is large. We are thinking about community inside the cities, so with many users and so on. So in general, it is needed a tool in order to forecast the production in the next hours or the day, and then a coordination, so an algorithm, an optimization algorithm for the units. In particular, if you have a storage system, battery energy storage system, in order to use the batteries in the best way, and also if you have a controllable loads, for example, the heat pumps can be regulated in order to consume in some times and not in the others, in order to reduce the price and improve the balancing into the system. And for these aspects, we say that tomorrow we will devote some time in order to describe also the algorithm and the approaches, or one of the approaches that can be used in these communities. I would like to end this talk asking once again if you have any question, any suggestion, and also for tomorrow lectures. Così tu che hai forte time?
So, session 2 is concluding with this beautiful slide of day ahead, intraday, and real-time optimization management tools. So we'll meet after lunch, then get the same place at 2:30. So all the participants who have registered for this course, they will lunch arrangement at this house. Guest house, if you have any problem of understanding what the guest house, ask our volunteers. They will show the direction of the guest house. So we'll meet again at 2:30. Don't be late. Take your lunch, and again we will meet here at 2:30. Yes.